These are the notes for Chapter 7 in Zybooks, CS 121. At the top of each of the sections here, you'll find instructed notes. Well, not each of them, but some of them. And if you touch the link here, it's in orange, it'll take you to Google Docs. You can download the files that are there. So there are several files. The first one we're going to do is the slice and stride. Slice and stride. So let me get that open so you can take a look at it. So slice and stride. This is really just several examples so you can see what the slice and stride do with a particular string. So I'll put the string in here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And you can put any string in there. If you want to test a different string, feel free to put a different one in. If I run this, it's going to show me what I'll get out for each one of the inputs here. So this is about learning slice and stride. So for this string, and it's a string that is 10, 11, 12, 13, 14, 15, 16 characters long. So it has indices 0 through 15. So we know if we wanted just the fifth value here, that would be 0, 1, 2, 3, 4. The fifth index would be 5 in this case. If we wanted -1, that takes the last one. -2 would be the second to last one. You can see that's what we got when we did those three. If I just put a colon in here with nothing in it, colon usually means a start to an end. It'll do the whole sequence. So it'll print out the entire sequence if I don't put anything in with the colons. But now the colon is going to allow me to put a range of values that I'm getting from the string or the tuple or the list. And I have the code here so that you can practice this with a list or a tuple instead of just a string, or in addition to just a string. So if I have nothing in the beginning to 5, that means I'm going to do from 0 to the index 4. So 0 to index 4, 0, 1, 2, 3, 4 is what I should get there. And you can see that there. From 5 to the end says I'm going to start at index 5 and go all the way to the end. So if there's nothing in the second part of the colon, I'll start at the first one and go to the end. So this broke this string into two pieces. Going from the beginning to 5 breaks it into two pieces and doesn't include the 5. From 5 to the end takes it all the way to the end. And you really could put a character larger, like the next one says 5 to 10. I could put a character like 5 to 100 here, and it should give me 5 all the way to the end of my string, even though the number is large. That was said for like a line in your Zybooks. If I'm going from 0 to -1, it means I'm going to include everything except the last one. 0 to -1, everything except for the last one. The last one was F. And 0 to -2 would be everything except for the last two. And you could play with that negative a little bit since you have this code here and see what the results are. You can get rid of some of the code and just play with one line of code if you wanted to. You could put a while loop in here so that you could give it some code. See how it looks. So if you have 2, the first is the beginning. It's taken to be 0. You're starting at the beginning index. And the second one is the end one. And if that's blank, that will just be the length of the list. So this goes from, in ours, 0 to 16 would be the length of the list, which means it does indices 0 to 15. If you just have the third variable, that means that you're going to do from the beginning to the end. That's the whole string. So you think of this as a whole string. The beginning to the end, you're going every other one. So we're starting at the beginning, that'd be 0, and every other one. If I start at 1 and do every other one, I'm doing all the odd indices. This one starts at 3 and does every fourth one. So that'd be 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Every fourth one. And this one's going to decrement, so this will write the list backwards. So it's going backwards. So starting at the beginning, going to the end, but it's starting backwards. So negative F. So basically the first two say, let's do the whole list, and we're going to go through -1. The whole list going through -2 is going to start with the last index and then skip every other one. So you can see this one looks like the odd one backwards because of the length of our list in this one. So looking through this section, they give you lots of examples of string slicing. But you're basically thinking, I've got 3 different numbers in here. The first is the beginning, the second is the end, and then the third number, if I'm given a third one, will be the stride, which is how I'm going through the string, or list, or tuple. In 7.2, we want to be able to format tables. So I'm going to look at 2 files here, making table and multiplication table, and it has some formatting in it. The other 2 are taking these 2 and taking the meat of the program and putting it into functions. You will be required to do that aspect for the test. So the first one, making table.py, I've got a list that's coming in with some students and some grades. And I don't think they all have the same amount of grades. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So some of them have more grades than others. So I've shown you a way to separate this out. So I've got to first make a blank string to catch the splits. So I'm putting in students and grades, a list for each index. So I'll have a list for each index of students and grades. So for the average, I need to make a list. And then for S and the students and grades, so that's for a student in there. So that would be one of these lines, which is now a list. I'm going to set the average to 0, and then for I in the range from 2 to the length of S, because 0, 1 are the names, the first and last names for the student. So this is just a regular program like we're used to seeing, but now we're putting in a different format. So the regular placeholder that we had, where we had the braces and then maybe nothing in here, or a colon with an S, or colon with a, like this, 0.3F. That's what we had. Now we're going to add more stuff in there that we can do. So that's all it is. More stuff is better, right? Especially at Christmas, Thanksgiving, birthdays. So if we have a caret like this, it means we want it centered. If we have a greater than, it means we want to have it right justified. If it's a less than, we want it left justified. Down here, we have a 12.3F. That just means that I'm going to have 12 characters long. 3 of them, of those 12, are going to be decimal places, and the decimal itself takes up 1. So on the left of those 4 places, the 3 for numbers and 1 for decimal, I have 8 left over that need to be filled in. So I'm tabbing over to the right. So basically this is a way to get you a tab in there. So if I run it, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if I count the other 4. So there's 4 on this side and there's 8 on the other, 12 in all. And I put a placeholder in there. It's not required, it's not needed. I just wanted to give you an example where you're seeing that placeholder. These are centered, and I might not want them centered. They may not look that good. I might want to go back and take the center off of them and maybe make them right justified. And I can do that pretty quickly. Just putting a less than instead. And I might want to do it in the header too. So you want to think about where these are. If I was designing this and I was going to use it over and over again, I might make these little string formats, like a format 1, that's a left with 12, and a format 2, so that I have a right justified with 12.3, maybe a format 3. Then I could string those together, because this is just a string in here. So I could make this somewhere else and be just a string. Let me run that again. We'll see how that looked. So now it's lining it up the way that I expect the table to line up. Maybe I don't want the dots here. Or maybe I do. Maybe I want them all the way across. So maybe here I also want dots. So I'll put a dot as the placeholder. If it's left justified, it puts the placeholder after, but it's the dot is going to be filled in for everything that isn't used in the 12. And then the dots here will be before the number. Dots here will be after because this is left justified. Notice that when I did the dot here, it did pop up a little menu for things. So start noticing when that menu is popping up. Let's run this again and see what happens. Run module. So now I filled in the dots in here. So everywhere I can see there's a Doug Deere down here. It has an 81.571 average. I've got these left justified for the names, right justified for the average so that the decimals line up. Now there are a lot of ways that you could separate that particular program into functions, but basically I need a header printed and I need the student averages printed. So I've got, and I might have had an input here, but the input here was just a list. So I'll put my list first. The header is just going to print out the header. Notice the star times 38. I was able to get 38 stars in there pretty quickly with this notation. Here I'm doing all the print work for the rest of the table here. All I'm doing is calling the header and the print in the main part of the program. For this part of the program, this little if statement, there are several of you that asked me questions about this. There's a website that tells you from Geeks for Geeks that'll go through and help you better understand. It really just means if I'm in the main part of the program, then I'm executing this. Else I'm going to execute when imported. So there's basically an idea that the whole thing that you're doing is an imported file if you don't have it in the main. The next program I want to look at is making a multiplication table. So again, I'm going to look at how the thing is formatted. So this says centered, and I've got 3 characters that I want it to be in. And then there's, after that, I want a vertical line. For the rest of this, I want right justified characters. And down in here, we're also going to want some centered with right justified. So thinking about how the multiplication table will be, let's run this and see what it looks like. It's maybe easier to see how the file looks. So first I ask, what's the largest number to multiply in? Maybe I'll put in 15. So I get a multiplication that's 15 by 15 multiplication table. It looks nice and sweet. Everything's lined up. If I run it again, maybe I'll put in 7. Then I can see that my multiplication table here is 7 by 7, still lined up. I also made it so that it wouldn't make the bar all the way out. So I made it so that it regulates the size of the bar. See that? One more than the end, just because I thought it looked prettier. Since there was one more over here. Technically not, because the one in the 10s, 11, 12, and whatever, I have an extra character in there. So looking at the file, we have A in range, 1 to n plus 1. We're doing this is the first column. So for the first column, and A in range, this is straight across the row. This is the row, first column, and now we're going to do this for every column. So we're going straight across the columns. Make sure you study this code. This kind of thing will be on the test. So make sure you're able to understand what this code is like. Most likely I would have you tell me what the code does for a small program like this, though you should be able to produce a table pretty easily. To get the horizontal line, I concatenated a new line with the dash character. So I'd have the dash like I have over here. And I wanted the n plus 1 times 5 because of the way that I aligned the characters up. This is 3 characters plus a vertical line, and then there's 5, however many n's we have. The n was what I got in from the user for how large I wanted the table. And n equals empty means that I'm not going to put anything at the end of it. And I won't go to the next line. Now I did it this way because down here I needed to go to the next line at the end every time. But I also needed this to continue on each line as it was going. So I needed to think about where those line separations were supposed to be. So I want to take this program and make it into functions. You should be able to take any little program like this that has a bunch of little pieces and make it into functions. So here I did the form like I said I was going to do. So the form, this is what a centered one with 3 places looks like with a vertical line after it. This one is a column with 5 spaces, right justified. So you can see where I've used those. There's actually Form 1 and Form 2 that I'm doing a little differently down here in this one. So I've updated it. See the global? I've updated so that I can fill in the character if I want to. So fill character is not equal to enter, so that means if you just hit enter at fill character time, then I can change my character to something else. And I'll show you what that looks like. But basically down here we have the meat of the program. We just want to print that this is a multiplication table, get a number in, print the header, and print the table. That's all we want to do. And then we put some more definitions in here. This fill form is about putting all those extra characters in. See the fill character here? I'm going to put in before the center and how many are in the column, or before the right justified and how many are in the column. So if I run this, it's going to ask me what's the largest number. Let's just make it like 6. Now the way that I've written this program, if I just hit enter, it's going to make it without any fill characters in here at all. So let's run it again with a fill character. So I'm going to make it 6 again so you can see the difference in the two. The fill character, let's put maybe the @ symbol. And it fills everything up that isn't that white space. So it fills all the white space up the way that I wrote the program. So if I look at the table now, it's really hard to see this, 1, 2, 3, 4, 5, 6, but you can see where the white spaces are for the program. So I wouldn't want to print it like this. But I wanted to give you an idea of what that code would do if you put a fill space in there. And it might not be too bad if I used a different fill space. So let me use a different one. Run this again. I'll do 6 again. And I'll put a fill character and maybe a period. See, that isn't too bad. I can see a little bit better how things line up. So for alignment and fill, you can actually put the name of the variable here. Name and name. I don't like when they use name because name and name sounds like I've put something fancy in there. But it's just a variable. So whatever the variable is here, so I don't have to have them in the same order. My list of variables back here with what's going into them doesn't have to be in the same order as here. So they show you what those fill characters will do. If you have no fill characters, it'll just put out 9 if it don't tell how wide the field is supposed to be. So this one doesn't have even how wide the field is supposed to be. Here, if you put a field width of 4, then it's going to give you some white space before it. That's what it automatically does, is right justified. 0 greater than 4, it's going to give you some zeros in there. This is the fill character. 0 is the fill character. Score is the variable that you're using. 4 is how many spaces that you're going to allow. And the greater than is right justified. Greater than again, right justified. If there were 18, if it was 18 instead of 9, of course you'd have 1 less 0. And then centered. This one's centered, so it puts zeros on either side. This would be very confusing if you were actually wanting these to be numbers that you needed to read. But if you were trying to enter like passwords or names for people and you were assigning numbers, like some of you had numbers on your Wingate University email address, those numbers are assigned kind of like this. Just put some numbers in a place where you need them. We've already worked with precision quite a bit, so this should be very familiar to you. It just is showing up a little bit differently now because you have a variable, you have the precision. 7.3 introduces more string methods. We've already had some. Length is a function, not a method. So when you have a string method, you'll have a dot. So whatever your string is called, it'll be a dot replace. There is a link further down in this part of the chapter in the string method section where you can go to the built-in types for the Python site. So they show you a lot of the string methods. So if you're kind of forgetting what the methods do or what you're supposed to put in, this can be a really good resource for you. As you scroll through here, they give you more and more examples of the different kinds of methods that we're going to be responsible for knowing. So find and rfind, reverse find, means it's going to start at the end and find. Find X returns the index of the first occurrence. Find X and the start, you could tell it after your first occurrence you found it, then you could start at the next index from that. This is used a lot. And then find from start to end, so it's looking in part of the string to determine whether or not the the string that you have, then X here is in that string, is contained in the string. And then the reverse find starts and end. Count X, it looks like a length kind of thing, but it's not. This is counting how many times like OO here occurs. So this was boohoo, so OO would occur there twice. I've made a string methods.py file so that you can play with this with idle. So I'm going to run this. And it's going to give me output so that I can see what each one of these does. So I'm starting with my string of banana. And my string.find gives me the index of the first n. That's going to give me the index of the first n, which is 0, 1, 2. That makes sense. Ban is a string that I'm looking for. And if I put bin in there, of course I wouldn't find it. The index of the first string that has ban in it is starting at 0. And the first one is at 1. Find an starting at index 2, that's 0, 1, 2. The first an will be at 3. This one is going from 2 to 4, and you can see from 2 to 4 that'd be 0, 1, 2 to actually to 4. I don't include the 4, that would just be NA. So AN doesn't show up there at all, and -1 means that it's not found. So I've given you several of these to play with a little bit further. You could get rid of some of these and play with it, or you could just continue working with it as it is. I found it pretty useful when I put them all in one place and actually put something in that made sense to me to see what things did. Now there are a few of these functions that return trues or false. So looking at the next group of them, my string.count_a doesn't return true or false. That returns how many a's were in there, see? But here is all numbers or letters is false because my string now is CS121 with some dashes in it. So I'm now working with this string, CS121 with some dashes and some white spaces. Is a digit is false because it's not just a digit. Is lower is false because there were some uppercase. Is upper is false because there were some lowercase. And it ignores things that don't really have an upper lowercase. When it does is lower or upper. So is space says whether or not the thing is a bunch of spaces. So the whole string is what it's looking at, like at here. I could look at one place in the string to see if it's a space. So I maybe want just one index. So I could alternately put a bracket in here with a number and see if that particular one is a space. That's usually how these are used, one at a time, but it doesn't have to be. Starts with X, X is spaces, so starts with X is a true statement because it does start with a space, and ends with a space. Well, it does end with a space, so that's a true statement too. And that brings us to the end of the true-false kind of methods that we have. So the first one here, capitalize, just capitalizes the first of the string. In our string, the first one is a space, so you're not really seeing that it capitalized that space because it doesn't make sense to change it. Lower turns the whole string to lower. Notice this is all lower. And then upper takes the whole string to upper. So all the characters that can be made uppercase will be. The strip here strips the white spaces from the beginning and the end, so there won't be any space back here. Up here there should be space, see? There's space, but down here there's no space. Stripping the white spaces is pretty important in some parts of programming, especially if you're putting things on the web. The title is going to change the first letter of every word to a capital. So intro to programming becomes CS capital intro capital to capital programming. And I think usually in titles the word to wouldn't be capitalized. So you want to be a little bit careful using that. Here we're replacing. So I've got some replace functions here. So I wanted to replace all the O's with something else. So I'm replacing all the O's in here with $4 signs. So all the lowercase o's get replaced with $4. Here I'm replacing all the spaces with nothing. So when I replaced, it put it all the way to the beginning. See? All the spaces, it took all the spacings out of the whole line of code. So that's one way to get rid of all the spaces out of a string. If you actually want English in there, you want to keep the spaces though. So be careful with that one too. Here for banana, this is from my string at the beginning, and that was our banana at the top. So for banana, I want to go through and replace all the A's with U's. And the second one, I replaced all the A's with U's. No, I replaced the first one, see? First occurrence. So this tells me how many of them I want to replace with U's. So there's an optional third one that's in here. The replace definitely has to have two. I'm taking this character and replace it with this one. That's true every time. And then the third character tells you how many of those you want to replace. So I only replace one. So there are a few string methods that you're really going to want to become familiar with, and we kind of went through the ones that you should be familiar with. You want to be careful when you're comparing strings. This is a pretty important concept through all of programming. In some languages it's more difficult than others. But here, if you're using the less than or equal to, greater than or equal to, you're comparing the links and whether or not it's upper and lowercase, things of that sort, where they are in the alphabet. The equality is whether or not they are exactly the same string, not the same object. So membership operators and identity operators are ones that we want to look at too. So in, not in, is not. So the comparisons here, hello is equal to hello. So the strings are exactly the same. These strings are not because there's one character that's not exactly the same, so they wouldn't be the string. Is Yankee bigger than Amy? And that would be true because the first character of the left side is further down the alphabet. So you can think of this as like 26 and this would be A. Well, actually 25, X, Y, Z, 25, and this would be A. Though if you were looking at indices, this would be 0 and this would be 24, right? Although, remember the ASCII, I think A started at 65 or something like that. So that's really what it's looking for, is looking at the ASCII. Here we have Yankee Sierra and Yankee Zulu. Well, this one's further down the alphabet. Everything matched to the first, so it's going to go matching all the way to the first character, and whichever one is further down the alphabet is the bigger one. So this one was the bigger one, so this ends up false. Seth and Joseph is a true thing. Joe and Joseph is not because the case is not the same. The last new concept for Chapter 7 is split and join. So being able to take a string apart, split it, and be able to join it back is kind of important in programming. So I have this file, split and join, so let's take a look at that. I've got each line of the poem and the author's name, any spaces that I need, blank lines, I've also got in here as one list. So if I print the poem, it'll just print out the list. If I print with some ands in between and do a join the poem, so I'm going to join all the pieces together, I'll see what that looks like. And then I want to do every line and join the poem, and we'll see what that looks like. Then we'll do some splits and put some A's, split along the A's, so you get an idea of what these are. Now this is a split on just one line of it, poem 1, so that's the author's name, poem 1. I also want to do an A.join string 1, so we'll see what that looks like, and an alpha.join string split O, so we'll see what that one looks like. So let's run it. So the first one prints the poem, and the poem is a list, so it prints out the whole list just like it was. The next one has an and a dot join, so it took every line of the poem, everything that's in the list, every element of the list here, every element of the list in there, and put an and in between, which isn't very useful as far as printing out a poem. But I'm trying to make a point that you could put anything in here and join this thing together. Now in the next one, I'm doing a join with the next line. So the join with the next line, and I'm collecting it in string. I'm not just printing it out. I wanted to show you that you could do this join and then you'd be able to collect it in a string and then you could put in the string. So that prints the poem, which is absolutely lovely. The fog comes on little cat feet. So there's the poem that gets printed by that. Then I put a blank line. This is a blank line. Now I'm taking just poem 1, which is the author's name. Poem 1. And I'm splitting it. By Carl Sandburg got split into a list. So I took an element in the list and made a list out of it. Then I split that one with A's. So the split here with nothing in there splits on blanks. So if you have a string with no blanks, nothing gets split. But if you have, you can also split it on any character. So here I split it on A, which isn't all that useful, but you can see all the A's were taken out, all the spaces were left in. There were 2 A's in the original, so there ended up being 3 separate splits. I can also do a join once I have the string 1. Notice here I split that one. I did a join with a lowercase a. So I split it up and I replace. I could have done a replace, but I split it up and I put a lowercase a in when I joined it. And then I could also join it with anything else. So here I did the string split, so this string up here with the poem, and I split out all the O's and I replaced all the O's with an at. So I end up with a poem that looks like this, with O's, all the O's becoming at. Now that was all lowercase, because if any uppercase were in there, that would be replaced with just, that wouldn't be replaced, because the only thing I've asked it to replace is the lowercase. So you want to think about cases when you're doing joins and splits. I wanted to remind you in Lab 7.5.1 of the short notation for an if-else. So you could have written this in if-else, and by all means do, but if you have just an if and then an else, you can write it in one line like this. I collected the string and then I printed the string. In Lab 7.6, you're going to split Pat Silly Doe like this. You want the last one, so that is the 0, 1, 2 index for what you split. And then you want the first digit of the first one. So this would be, if I called it string, str, it'd be 0 in the first set of brackets and 0 in the second set of brackets. So let me show you what that looks like. So if I get my name in and split it into a list, that means that I'll have list 0 and list 1. List 0 is Susan, list 1 is Lauer. And of course, if there's a middle name, that I'd have to say that I guess you need to think about the length here. That's what you need to do. So if I run this program with 1, 0, that's looking at the second one, the second element in my list, which is Lauer, and the 0 would be the location of the first part of the string, because name 1, Lauer, is actually a string, and then it has a location. So if I run it, I end up with L. In the 7.9 lab, we have a really quick way to determine whether something is the same as its reverse. So we could basically get a word in, see if the word is equal to the word in reverse. So let's code here. From the beginning to the end, so the whole screen going backwards is the same as the word itself. We print word. So if we try this with radial, it shouldn't print anything. But if I change it to radar, it should print just fine. For 7.10.1, you want to split up the string that's coming in and look to see if the first character is a capital. And if it's capital, then you'll write it as part of the string that you're collecting, or you'll actually print it out. You'll have 2 inputs for 7.11 lab. You'll have a character, and then you'll have a string, which you'll split, break into a list, and then you'll see if the element that you're given, the Z in this case, is in either any of these. If it is in there, then you'll print it out. So it wasn't in hello, it is in zoo, it wasn't in sleep, and it was in drizzle. So you're going to do a for loop with an in. 7.13 is having you put a table and then make a visualization of that table. So you have a visualization like this. A table and then a visualization. So this one's a little involved. You might want to wait until after the test to actually work on this one if you don't have much time this week.